Hey, welcome back to our pre-calculus summer lessons. This is lesson number 3, and today we're going to talk about slope. So let's just start with the basics. The slope of a line. We use m to represent slope. The slope of a line, the formula is y2 minus y1 divided by x2 minus x1. So if I had 2 points, let's say that we have the point 3, 8 and the point -1, 4. Okay, if I label these points, I'm going to call this x1 and this is y1, x2, y2. The important thing is that we have to be consistent. So it doesn't matter. I could call this x2, y2, and I could call this one x1, y1. It doesn't matter which one we call 1 and which one we call 2, as long as we're consistent. Okay. So let's go ahead and calculate the slope made by these 2 points. So m equals y2, so that's 4, minus y1, which is 8, divided by x2, -1, minus x1, which is 3. So we have 4 minus 8 is -4, divided by 1 minus 3, which is -4. So that gives me a slope of 1. So if I'm just given 2 points, I would use the formula to calculate the slope. Now, if I saw that those 2 points on a graph, right, let's go ahead and plot those on the graph and take a look at that. Let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here's the first point, right? This is 3, 8. And then the other point is -1, 4, right here. Okay, so here's the line made by those 2 points. Okay. Now I could calculate the slope graphically. So remember, slope is rise over run. So it doesn't matter which point we start at. So I'm just going to start down here. In order to get, we'll call this point A. In order to get from point A to point B, I have to rise 1, 2, 3, 4. So I'm going to rise 4, and then I'm going to run 1, 2, 3, 4. Right? Rise over run. Run is going horizontally. So we see we have a slope of 1. Now notice if I went the other direction, so let's say that I started here B, I'm going to rise, but it's actually not rising, right? I'm going down. 1, 2, 3, 4. So when we're talking about slope, if I go down, that's negative. So it's -4. And then I'm going to run to the left, 1, 2, 3, 4. So again, with slope, right, if I go down, it's negative. If I go left, it's negative. Down is negative, left is negative. So I went down 4 and then I went left 4. A -4 over -4 gives me +1. So here we found the slope just looking at the points using the formula. And then we found the slope looking at the points on a graph. Okay. So this should be something that you're familiar with, right? We did this in Algebra 2. We did it in Algebra 1, right? Let's see. Let's look at an equation, right? Remember the equation y equals mx plus b, right? So what do the parts of the equation represent? Well, the m, there's my slope. And here we have b is my y-intercept. Slope and y-intercept. So if I have the equation y equals 1/3 x plus 2, what's the slope of that line. The slope of that line is 1/3. What's the y-intercept of that line? 2. Now, in Algebra 1 and 2, we just let you say it like that, y-intercept is 2. But let's actually look at the graph, okay, and see what's going on. So just a couple reminders. First off, I know that this is linear, which means it's a line. I know that because it's in the form of y equals mx plus b. Okay. Now, in order to graph that, I'm going to plot my y-intercept, which we said is 2. Now, it's not actually 2. What is that point there? Well, this point is the point 0, 2. So when you're asked the y-intercept, you should give it as a point, 0, 2. Your y-intercept is always going to have an x value of 0. Okay, so when you're asked the y-intercept, you should be giving it as a point. Okay, now we have 1 point. How many points do we need for a line? We need 2 points. So I'm going to use the slope, rise over run. In this case, it's 1/3. So I'm starting at this point. I'm going to rise 1, and I'm going to run 3. So I go up 1 over 3. There's my other point right there. Now I have my line. Okay, so that's how I graph a line using slope-intercept form. Right? Y equals mx plus b is slope-intercept form. Okay, so anytime I have an equation in that form, it's pretty easy to graph. Let me show you another one. Y equals negative 3/4 x plus 4. Okay, so let's graph that. All right, get some points on here. Okay, so what's the first thing we do? We have to plot our y-intercept. So it's crossing the y-axis at 0, 4. So there's my y-intercept. And now from the y-intercept, we're going to apply the slope of negative 3/4. So negative means, right? Negative means down. Negative means left. Okay, so if we look at this slope, we could say it's negative 3 over positive 4, or we could treat it as positive 3 over negative 4. Okay, so we're going to look at that. So if I have negative 3 over positive 4, that means I'm going down 3 and to the right 4. So there's my point. Okay, I can draw that line. Okay, extend it out a little bit. Okay, so, but what would happen if I had said 3 over negative 4 instead? So that means we would go up 3, right? Positive 3 means rise 3. Negative 4 means go left 4. So I would go 1, 2, 3, 4. And there's my point. So although I would get a different point, I'm getting the same line. It's just a different point on the line, but it's the same line. Okay, so that's called the slope-intercept form. Sometimes the equation is not in slope-intercept form, but it's in general form. So general form looks like this. AX plus by equals c. So if I have the equation 2/3 x plus 3y equals 1. Is that in general form? Well, it's actually not, because general form says that the a and the b have to be integers. And do we remember what an integer is? An integer does not include fractions or decimals. So I have to modify this. How would I get rid of the fraction? We can multiply everything by 3. So in doing that, we're going to get 2x plus 9y equals 3. Now this is in the general form, but the general form is harder to graph from. So if I wanted to graph it, or if I wanted to know what the slope is, I'd have to take that equation and change it to slope-intercept form. So how would we do that, right? Slope-intercept form is y equals mx plus b. So we want to isolate the y. So let's subtract 2x from both sides. And then let's divide by 9. So y equals negative 2 over 9x plus 3 over 9. So my slope-intercept form would be y equals negative 2 over 9x plus 1/3. What's the slope of that line? Negative 2 over 9. What's the y-intercept of that line? The point 0, 1/3. Okay? So we have slope, finding the slope from 2 points. We have the slope using rise over run from the graph. And we showed how we can go up and to the right is the same thing as down and to the left. We have the slope-intercept form of our equation, y equals mx plus b. Right? We can graph the line from that. We showed a slope-intercept equation with a negative slope. We looked at the general form of an equation, of a linear equation. Okay, and as I'm looking at that, I'm thinking, let's just make sure that we understand the slope of a line. Okay, so the slope of a positive line or a positive slope would look like this, right? Positive slope means it's going uphill. This has a positive slope. Okay, negative slope looks like it's going downhill. So this has a negative slope. Positive slope and negative slope. Then we have what we call a zero slope. And zero slope is a horizontal line. That has a zero slope. And then we have an undefined slope. So undefined slope is a vertical line. So why is this pink line called undefined where the blue one's called a zero slope? Well, let's just pick a couple points here, right? So let's just pick, we'll call this negative 1, 2. And then we'll call this point here 2, 2. Right? Using our slope formula, y2 minus y1, so that'd be 2 minus 2 over x2 minus x1. So I would get 0 over 3. Anytime we have a 0 in the numerator, it equals 0. Right? Let's pick 2 points over here. Let's call this point negative 4, 1. Oops. Let's call that negative 4, 1, and then we'll look at this point down here. We'll call it negative 4, negative 3, right? Let's see what happens with those 2 points. So I would have -3 minus 1 over -4 minus -4. So we'd get -4 over 0. Anytime I have a 0 in the denominator, the slope is undefined, or the fraction is undefined, right? So a horizontal line has a slope of 0. A vertical line has an undefined slope. Okay? Okay. Let's pursue the idea of slope just a little bit more. What if two lines are parallel? Right? Two lines are parallel. If they're parallel, then their slopes are the same. The rise over run is the same. Okay, so parallel lines have the same slope. How about perpendicular lines? Perpendicular lines. Right? We know that they make right angles. Right? Perpendicular line. We have a negative reciprocal slope. So for instance, let's call this line 1 and we'll call this line 2. If line 1 has a slope of, let's say, 2/3, and line 2 has a slope of negative, right? Negative reciprocal. So reciprocal means flip it upside down. -3/2. These two lines would be perpendicular. Line 1 is perpendicular to line 2. Okay? So if line 1 had a slope of -4, and line 1 was perpendicular with line 2, what would the slope of line 2 be? Well, first off, it's going to be positive, but it's the reciprocal. So instead of 4, remember that's actually 4 over 1, it's going to be positive 1 over 4. Those two lines would be perpendicular. Okay? Okay, so let's look at a couple other examples. Let's see here. Okay, so let's say that I have the equation, right? I have y equals 1/5 x plus 3, okay? I want you to give me the equation of a line that is parallel and goes through the y-axis at 0, -2. Okay? So in order to write the equation of a line, I need the slope. So what's the slope that I'm talking about? Well, it's parallel, so it has the same slope. So that would be 1/5. So it's 1/5 x. And then how about the y-intercept? What will that be? -2. So 1/5 x minus 2. Okay? Now give me the equation of a line that's perpendicular to this line and goes through that point. Well, that would be y equals -5x minus 2. That one's going to be perpendicular. This one will be parallel. Okay? Okay. Since we're talking about writing equations of lines, can you give me the equation of a line that goes through the point 3, 5 and has a slope of 1/2? Well, in order to do that, I'm going to use what we call the point slope equation, which looks like this. Y minus y1 equals m times x minus x1. That's our point slope equation. Okay, so we have a slope-intercept equation. Right? And the name of it tells us exactly what information we need. Slope-intercept equation means we need the slope and the y-intercept. Point slope means I need a point and a slope. Do I have a point and a slope? Sure, right here. So let's write the equation of the line. Y, right? This is my x1 and this is my y1. So it's y minus 5 equals 1/2 x minus 3. Let's simplify that into slope-intercept form. Y minus 5 equals 1/2 x minus 3/2. So now we'll add 5 to both sides. So we get 1/2 x minus 3/2 plus 5. So let's simplify that. Instead of 5, let's think of that as 10 over 2, because we need a common denominator, right? So y equals 1/2 x minus 3 over 2 plus 10 over 2, which gives us 1/2 x plus 7 over 2. There's the equation of my line in slope-intercept form. I started off with a point and a slope, and I have the equation. Okay? Okay, let's do another one. Let's say that I have 2 points, -4, 5, and +4, 3. I'd like the equation of the line given by these 2 points. What information do I need? Right? I either need slope and a y-intercept. Do I have a slope? Well, I can figure out a slope. Slope equals 3 minus 5 over 4 minus -4. So that gives me -2 over 8, or -1/4. Great, I have a slope. Do I have a y-intercept? Well, remember, y-intercept means that the x value has to be a 0. So I do not have a y-intercept, so I can't do that. So what's my other option? Right? I can do slope or y-intercept, right? And that would be y equals mx plus b. Or I can do a point and the slope, and then I'd use y minus y1 equals mx minus x1. So do I have a point? I sure do. I have 2 points. Do I have a slope? Yes, I do. So let's use point slope. So does it matter which point I use? Well, let's try and see. Okay, I'm going to use the first one. So it's going to be y minus 5 equals -1/4 x minus -4. So y minus 5 equals -1/4 x. Now this is the same thing as plus, right? Minus, minus. So I'm going to distribute -1/4. -1/4 times +4 is -1. Adding 5 to both sides, we get y equals -1/4 x plus 4. So there's the equation of my line. I'm going to do it again, but this time I'm going to use the other point, and we'll see if we get the same equation. Okay, so let's see here. We're going to do y minus 3 equals -1/4 x minus 4. So that will be y minus 3 equals negative 1/4 x plus 1. If I add 3 to both sides, I get y equals negative 1/4 x plus 4. We got the same equation using both points. So it doesn't matter which point we use. Okay? Okay, let's see here. Here's a question for you. Let's say that I have the point x comma 3 and 5, 9. And the slope is 2. Find the value of x. Well, slope equals x2, y2, goodness gracious, y2 minus y1 over x2 minus x1. Okay, well, slope is 2, so 2 equals 9 minus 3, there's my y2 minus my y1 over x2, which is 5 minus x. So let's solve this equation. So I'm going to multiply both sides by 5 minus x. Right? So over here we get 10 minus 2x equals 9 minus 3, which is 6, right? These are going to cancel. So this gives me negative 2x. I'm going to subtract 10 from both sides, so we get negative 4. Dividing by negative 2, x equals positive 2. All right? Okay, so I'm going to stop there. There is a worksheet. There's a link to a worksheet in the description section of the video. Okay, link to worksheet in the description section. Again, do not open it in Google Docs. You can either copy it down on paper, or you can work directly in Notability, or you can print it out and work on it. But if you open it in Google Docs, sometimes the symbols do not work. So to avoid that headache, do not open it in your Google Docs, okay? So there should be a link right below this video in the description section, okay? I will see you in the next video.